So in this equation, we have this absolute value term. And to solve this algebraically, you have to consider the cases where this would be positive and negative. So we'll start with the first case where it is positive. And in that case, we can write absolute value of x plus 2 as x plus 2. So this is the equation we'll solve. And you always want to check if these solutions would satisfy that condition. So here's the first thing to note is don't do the expansion. I've seen students do this part. And of course, you will eventually get the right answer, but don't go there. Instead, note that we have x plus 2 here, x plus 2. So bring them both to one side and then factor out x plus 2. You'll see this will be less work. So you'll get x plus 2 minus 1. And so now we have it in factored form. And the two solutions are minus 2 and minus 1, and they both satisfy this condition. So those are my two solutions so far. The other case would be when x plus 2 is negative. In that case, this becomes equal to minus of x plus 2. I can move them to the same side. And then again, factor out x plus 2. Don't do this expansion, which eventually you'll get a quadratic equation, but then you'll have to factor it again. And now my two solutions are minus 2 and minus 3. This one we've already obtained here. You can kind of ignore that. This is the new one, and it does satisfy this condition. You always want to check with these types of equations when you set that condition that does it satisfy. And minus 3 is indeed less than minus 2. So the three solutions are minus 1, minus 2, minus 3. They're asking for the product. So the product would be minus 6. So the answer is A. Now, just one other thing I wanted to just share with you qualitatively what the graph of these two functions would look like. Because what they're looking for is when they both have the same value. And this graphing part might come handy in other questions. Maybe where they're asking how many solutions are there, where they may say 1, 2, 3, so on and so forth. So these are some of the common functions, and it's important to know what the graphs look like. So x plus 2 squared, that's going to be your upward opening parabola, and the vertex would be minus 2, 0. So it's going to look something like that. That point is going to be the y-intercept. And then this would be, again, in general, graph of y equal to absolute value of x is this. Also good to know. And here it's shifted. That same graph is shifted to this point, minus 2, 0. So it's going to look something like that. So we expect one solution here because we're looking for points where they're both equal. And then this is obviously the vertex also is, and then you have another one. So this might be helpful qualitatively in other questions because we don't really know how else they're going to test this idea. But it's good to know these pieces for these types of questions. But to summarize, the answer is A.